Suppose that we have event A and event B. Use the golden rule of probability law, which states that probability of event A or event B occurring is equal to the probability of event A happening plus probability of event B happening minus the probability of A and B. And this relates to any two events. And for these events, if they say something is mutually exclusive, they're simply saying that the probability of event A and B should be equals to 0, and the probability of event A or B should be equals to the probability of A plus the probability B. This is really important to know because they'll be really asking these questions considerably frequently in probability. And since we're on this tangent, let's include complementary events. Complementary events simply means that given the probability of event A happening plus the event A not happening, the sum of that should give you 1. So let's really play around these equations to answer the following question as a fundamental to probability. In a random experiment, it was found that the probability of event A is 0.25, B 0.5, and the probability of A or B is equal to 0.625. First question says calculate probability of event A and B happening. So these are any two events, so we can immediately use the probability law. How do you go about it? We know what the probability of A and B in this case is. We know that it's 0.625. We know what the probability of A is, 0.25. And you know what the probability of B is, it's 0.5. So we can just simply solve from the probability of A and B. So which would be written simply, it will be 0.625, 0.025 plus 0.5 minus the probability of A and B occurring. So we can just really group these together, or we can take this to the left hand side and bring this right hand side. Probability of A and B will be equals to 0.25 plus 0.5 minus 0.625. So the probability of event A happening and B happening, when you plug that into the calculator, we should get 0.125 as I'm getting in my calculator. So that's the probability. We've answered the first part of the question. So the second part of the question is asking, determine giving reasons if event A and B are mutually exclusive. So the first part is mutually exclusive. For these events to be mutually exclusive, these are the two conditions. Is that event A and B should be equal to 0, but we already calculated previously that event A and B are equals to 0.125, which means they are not equals to 0. Therefore, they are not mutually exclusive. Simple as that. So the third question goes to ask, determine giving reasons if event A and B are complementary. Are they complementary? Or they're not complementary? They cannot be complementary because they are also not mutually exclusive. So they cannot be complementary. Event A or event B is not equals to 0. So therefore, they are more independent events. And therefore, they are not complementary. Let's continue with this chain of thought to the next exercise. We'll be given events A and B, told that probability of B is 0.3, probability of A is 0.45, and the probability of A of B is 0.615. So now we are asked to determine whether events A and B are mutually exclusive. How are we going to do that? Mutually exclusive. We know that for events to be mutually exclusive, it's 2.1. For events to be mutually exclusive, we know that the probability of event A and the probability of event B give you 0, and the probability of A or B will be equal to the probability of A plus the probability of B. So with these two conditions, we need to go back now and try and answer the question based on that. So we know that the probability of A or B is equal to 0.3, 0.615. So let's calculate what the probability of A or B is. The probability of A or B equals to the probability of A, and the probability of A is given by 0.45 plus the probability of B is given by 0.3. And this gives us the sum total of 0.75. And for this to be mutually exclusive, we know that probability of A or B should be equal to 0.75, but we told that the probability of A or B is equal to 0.615. So therefore, these events are what? Not mutually exclusive. So we can say that event A and event B not mutually exclusive. So let's go to 2.2. So it's determine the probability of event A and the probability of event A and B. So the probability of event A and B, we can solve this using the probability law. It says the probability of any two events. This law applies to any two events, like the holy grail of probability. So we have the probability of event A, which is 0.45, probability of event B, which is 0.3, probability of event A or B, which is 0.615. So we just substitute the event of probability of A is 0.45, of event B 0.3 minus the probability of A or B is 0.615. And we get, when you substitute that in my calculator, we're getting 1.35. That's the probability of event A or B. And lastly, last question is asking an important question. Are events A and B independent events? If they are independent events, what needs to happen? Firstly, we need to calculate what the probability of A times the probability of B gives us. In that way, to determine that these events are independent, this should be equal to the probability of event A and B. If this is equal, it means that the events are independent. Let's go ahead and do that. Probability of event A is 0.3 times probability of event B 0.45 which gives us 0, 1, 3, 5. And we know that the probability of A and B, of which we calculated in the previous answer, is 0, 1, 3, 5. Since these are equal, it suffices to say that event A and event B independent events. And we would have really given a good foundation into how to use the probability law, mutually exclusive events, independent events, and complementary events.